Okay, so we added to our table of contents. Let's go ahead. You might want to have some colored pencils, obviously, so you could take some good notes for yourself. So let's think about parallel lines. Parallel lines. When lines are parallel, what do they look like?
Two lines that are not connecting but go on forever. Like
go forever. So if things are parallel, what happens to their slopes? What do you think is true about the slopes of two parallel lines?
They're the same.
What? True. Tell me about their slopes. They're going to be the same, right? Because they're sloped either like this, or like this, or like that, or like that. It doesn't matter how they're sloped, but if one of them has a slope of 1/3, then the other one also has a slope of 1/3, because they have to be sloped the exact same way in order for two things to never ever cross. So when we're filling in the front of the foldable, slopes of parallel lines are the same or equal So they're going to have the exact same slope. So if I have two lines, and I know what the slope of this one is and the slope of that one is, and if they're the same, then we know that they're never ever going to cross. They're going to have a different y-intercept, because they have to cross at different spots, but they're going to have the same slopes. Easy enough to remember, because that kind of makes sense. Perpendicular lines. Perpendicular lines cross at a 90-degree angle, right? And we know our symbols for these. Make sure you know your symbols for parallel and perpendicular so that you don't have to write out the words over and over, because both words are annoying to write, right? Parallel lines, which is a symbol of two little lines. It could be straight up or a little bit slanty. But perpendicular lines are, let's write it first and then we'll talk about it. They are opposite reciprocals. Opposite reciprocals. Opposite reciprocals. We'll write it and then we'll put notes by it so we remember what opposite reciprocals mean. You guys should just leave them at home. Get in trouble. You're just going to die without them. Love them so much. That's them. Put a little heart on them. Maybe you should just sing some songs to yourself. Okay, what does the opposite mean? What's the opposite of a 10?
Negative 10?
Negative 10. What's the opposite of negative 1/3?
Positive 1/3.
Positive 1/3. So when I talk about opposite, I'm talking about change. You might want to put it in a different color. So you're going to change positive, negative. So if he's negative, you make him positive. If he's positive, you make him negative. So that's what we mean by opposite. Basically, they're talking about the opposite side of 0 on a number line. So if positive 5 is way down here on a number line, negative 5 is on the opposite side, same distance away. That's where they come up with that word. Reciprocals. Reciprocals, you need to have a fraction. So that's the first thing. You need to make sure they look like a fraction. Because reciprocal is when you do what with your fraction?
Flip it.
Flip it. So you're going to flip it. So you got to flip it upside down. So he needs to be a fraction. So clearly you cannot flip a decimal. You can't flip a mixed number. So you need to have him be a normal fraction with one number on top and one number on the bottom. So you can flip him upside down. Cool? You put little notes by these? So you remember you got to do both things. Change the sign and flip him. And then you're going to have perpendicular. Okay, so let's quickly review what y equals mx plus b means. Who remembers what stands for in y equals mx plus b? What do you remember?
Y is the y-axis. It's like the y number in a coordinate thing.
And that is true. We rarely plug it in, though, but you could for some situations. What were you going to say? M is definitely the slope all the time. You're not incorrect, Tyler, but we don't need that right now. You know what I mean? Because we're not going to sub anything in. But yes, if you had to sub in the y coordinate, that's where we go. So the M is definitely the slope. What do you remember? The B is the y-intercept. So we remember what M and B stand for. Slope and the y-intercept. Now, which thing are we concerned about when we're talking about parallel and perpendicular lines? We're going to be focusing, obviously, on the M, right? And if things are in this form, if they look like y equals mx plus b, you can easily see it, right? If these numbers are jumbled around and they don't look like y equals mx plus b, you need to make them look like y equals mx plus b first. Or you need to graph them in Desmos and find your slope by counting your rise and run, okay? So let's go ahead and just look at some equations below here. Let's go to this little table. I'm going to put a little note at the top of it. Let's put a little note that we want to make them look like, it must look like y equals mx plus b. So make sure your equations look like y equals mx plus b, which will require you to remember some algebra to move stuff around if needed. So we want things to look like y equals mx plus b. Because then we can find the m, because that's the only thing we want. We need m. So to find the slope of a line, we need m, obviously. If we want the perpendicular one, we need m. But then we need opposite reciprocal, right? So if we just want to know the slope of a line, we just got to find the m. Or if we want to know the slope of a parallel line, we just got to find m. If we want perpendicular, we do have to still find m, but then we need to find the opposite reciprocal of m. Flip him and change his sign. So, my first equation, you see him? Y equals 3/4 x plus 8. So does he look like y equals mx plus b? He looks perfect. So all we need is the m, right? Which is the m? What is the slope? It's just 3/4. Don't attach the x on it. It's just 3/4, right? Because we just want the m, we don't want mx. Okay, so if I wanted the slope of a line that's parallel to this, I would just use the exact same slope, right? So I would just say 3/4. So that means I'm rising 3 and running 4. So is this graph increasing or decreasing? Is it going uphill or downhill? Uphill, because if I start here, I rise 3, run 4, that means I'm going this way. Rise 3, run 4, and keep going that way. It's increasing from the left up to the right, correct? Because you always read graphs from that side this way. If I wanted the slope of the line that was perpendicular to that, you would need his opposite reciprocal. So what is his opposite reciprocal? Upside down and change the sign. Negative and 4/3. Because that means this guy, is he going uphill or downhill?
Down.
Down. And that's going to be true. If you have perpendicular lines, one of them's going uphill, one's going down. Unless they're perfect, they could be horizontal and vertical. But as soon as you tilt, you got somebody going uphill, somebody going downhill, right? Otherwise, you're not going to cross at 90 degrees, perpendicular. Okay, next one. Is he in slope intercept form?
No.
Y equals mx plus b? Kinda. What's the only thing that's wrong with him?
He's not like a fraction.
He's not a fraction. And you might want to change this to plus negative if you're talking about like identifying the b, but which we're not, but that's a good strategy. And he's not officially a fraction yet. So he is a 7. That is his slope. But we need to write him in fraction form. So what does the fraction form of 7 look like? 7 over 1. And obviously you're going to need that. Now, if I just said what's the slope of the line or the slope of the parallel line, 7 or 7 over 1, both are acceptable. These are both good answers. But in order to find opposite reciprocal, you got to think about going from the fraction form, right? So what's opposite reciprocal of 7 over 1? Negative 1/7, yeah. Negative 1/7. Go ahead, do the next one. Okay, so this looked like y equals mx plus b, correct? Okay, so what was your slope?
Negative 1 over 2.
Okay, and then your opposite reciprocal is what? Which is basically just 2, right? And you can, 2 over 1 is fine, but normal people just say 2, right? Some of you are not normal people, so that's fine. Cool with that. Alright, the next guy, does he look like y equals mx plus b?
No.
He does not. Now you guys do have some space right above on your paper here if you want to throw those two guys up here, or you might be able to squeeze down here. There's not a lot of space underneath there, but you do have some extra space right here. So let's just remember some things about moving stuff around and what's legal. So this one does not look like y equals mx plus b. So right now, does not look like y equals mx plus b. So I've got y equals 20 minus x. Okay, so what are some things I need to do to this guy to make him look like y equals mx plus b? I do have the y in the correct spot, right? And I do have the equals in the right spot. But he does not look like mx plus b. What do I need to do? Am I allowed to do this?
Yeah.
What's wrong with what I just did? So these two items are on the right-hand side. So I can move them around on the right-hand side, but you need to make sure that all signs stay attached to the correct numbers. So this is technically a negative 1x, correct? So if that makes you remember that, stick that stuff in there because I can move him over, but the negative is actually attached to the x. The 20, is the 20 a positive number or a negative number? It's a positive. So since I'm staying on the same side, I'm allowed to move terms around, right? Now if I wanted to move something to the other side, I'd have to add or subtract it, right? So I can just do that, but do make sure that you keep negatives attached to the whatever's on the right of it, correct? Okay, so now he looks like y equals mx plus b. I'm going to go ahead and throw him in my chart down here. Y equals negative 1x plus 20. Okay, and so then I can easily find my slope of him and or the line parallel to him. What do we got here? What's his slope? Negative 1. And obviously that's the same as negative 1 over 1, right? If you want to think of him as a rise over a run. That is a rise, negative 1, run 1. So what does that line look like? Down 1, over 1, down 1, over 1. So he is a nice diagonal. I guess he would be high up though, because he'd be crossing at 20. Okay, what is the opposite reciprocal? Just 1, right? Flip him upside down and change his sign. You just get 1, right? Or 1 over 1. Rise 1, run 1. Okay, next one. Is he in slope-intercept form? Heck no. Okay, so I'm going to write him, you can write him up on the top so you can move stuff around, especially if you have forgotten some of your algebra. So 3x. So remember, I want him to look like y equals mx plus b. So if I think about this, I don't know why that stupid box keeps popping up. It's annoying to me. So if I look at Mr. Squiggly down the middle here, I want just y on that side, correct? I only want y on the left-hand side. So who's got to get the heck out of here? This -2 does, and this 3x does. The whole 3x needs to come over here, doesn't it? How do I move a whole term?
Subtract.
I got to add or subtract him depending on his sign. So in this case, I will be subtracting 3x from this side and subtracting 3x from this side. Don't do any illegal algebra. What will I be left with on the left-hand side? -2x. Don't lose the negatives. Remember, if it helps you to do plus negative, so you remember, do that, is equal to. Now, are these like terms on the right-hand side? No, so you cannot combine them. So technically, you could put them in any order, but since we want it to look like mx plus b, let's put the -3x first, because that way that puts him in the right spot that I want him. -3x, and that's a +8. Make sure you keep your negatives and positives attached to your correct terms, right? Do I have y all by himself over here yet?
Yes. No. Yes.
Halfway. What needs to go now? That -2. How do I get rid of a -2 that's touching that y? You got to divide it out. Now remember, when you have two terms over here, you need to divide everybody. So if you divide him by -2, you got to divide this by -2 and this by -2, because they're two separate terms over there. So on the left, I have -2 divided by -2. That just gives you 1y, which is just y, which is what I wanted, right? Okay, on the right-hand side. Now here's the deal. Now you might be tempted to grab a calculator and do -3 divided by -2, and then you'll get a decimal. But working with slopes and opposite reciprocals, you don't want to ever have a decimal, right? So what is negative divided by negative? Positive. So just leave him +3/2x. Do not change to decimals, because you cannot opposite reciprocal a decimal. Plus, and what's this? -4? And now, does he look like y equals mx plus b? Yes. Okay, I'm going to put him back over here in my table. Y equals 3/2 x plus -4. Or you could have just written -4 also if you really wanted to. Okay? Okay, so what's our slope then? (3/2). And then what's your opposite reciprocal? (2/3). So if you were to graph them, if you had one line that rose 3 and ran 2, and then you had another line on the same graph that went down 2, rise -2, and run +3, those lines would cross at a 90-degree angle. Cool? Okay, let's go ahead and open the foldable. Yeah. Yeah, did you fill your pass? Okay, open your foldable. All right. Super easy. We just want to decide, are these parallel, perpendicular, or neither, and justify. Justify means gives a reason why, right? No sleepy time. Wakey, 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 wakey. Okay? Okay, the first one up there. So if we want to decide if these two are parallel, perpendicular, or neither, what do we have to look at only? What do we got to look at?
The slope.
Look at the slopes. So we're going to look at the slopes. We need to find the slopes. Make sure they look like y equals mx plus b, because then you can find your slope right here. Correct? do those two equations, or do they both look like y equals mx plus b? Yeah, y equals mx plus b, y equals mx plus b. Now obviously you can change that negative, the subtraction to a negative 2 if you want to get all official. But, so what are the slopes of these guys? Slope is 3, slope is 3. So what do you know about that? Same slopes are what? Parallel. Same slopes. And that means that they are parallel. Same slopes means that they are parallel. Oops, that's a little arrow. Next one. Do those look like y equals mx plus b? Y equals mx plus b, y equals mx plus b. Yep. So find your slopes. What are they? Okay. So our slopes are -2 and 1/2. Those are my slopes, right? So are those parallel? Are they perpendicular?
Yes.
Why?
Because they have opposite reciprocals.
Okay, so they have opposite reciprocals. And that means that they are perpendicular. Perpendicular. Cool? Okay. The next one just has a picture, and we need to decide if they're parallel or perpendicular. And remember, you are not going to eyeball it, okay? You're going to actually find the slopes. This will be good because we got to count some rises and runs, correct? So let's find the slopes of these babies. Okay, you might want to do your lines 2 different colors like mine. You can pick any color you want. Just don't do super dark because you need to be able to see the grid underneath. So we're going to have to find the slopes of both of those. Now, when you just glance at those, do you think they might be parallel or perpendicular?
Perpendicular.
They might be perpendicular. But sometimes when you have a graph like this, it might be just like one little notchy off, and it might look perpendicular, so you're going to double check it. Because if they put it on OST and it's super close, then they're going to make it look like it can go either way. You know what I mean? Okay, so which line do you want me to do first? My red one or my blue one? Blue? Okay. Everyone look at whatever line this is for you. We're going to do that guy first. Okay, so what do we do to find slope?
Rise over run, or you can stack and subtract the coordinates.
Yeah, so you could identify some coordinates and do your difference of the y's or difference of x's. Or you can find 2 pretty points, meaning where they cross the graph. Like this purple one and this purple one, these are pretty points. This blue one is not pretty, this one's not pretty. So pretty points means it crosses on the grid and it's exactly on, right? So find 2 pretty points on the blue one. Does anybody want to pick me out some pretty points?
1 and 2.
1.
My mistake, sorry.
-2, -1. This one? Is that cool?
Yeah.
Give me another pretty one. Can I do this one right here on the y-axis? Okay, so if I counted the rise and run in between those 2 points, and then remember, it doesn't matter what points you pick because you're going to get the same. If I counted the rise over run, that is rise 1, 2, 3, 4. That's bubbles, right? And 1, 2. So it's down 4 and to the right 2. So remember, our slope is rise over run, don't mess up your negatives. That is the number one mistake people make. That and not counting bubbles correctly. Well, I can't help you if you can't count a bubble. So that is rise what?
Rise of 1.
-4 and run 2. Okay, and we can simplify. What is -4 over 2? Just -2? And you could think of -2 over 1 if you want. Okay, now we need the slope of my red line. That means I got to find 2 pretty points. I'm going to keep using this point that I started with right there, and then I'll just use the origin there. Are you guys cool with that? So between those, how much do I have to rise and run? Up 1 and over 2. So are those both positive? Up and to the right? Yep. So my slope is going to be rise 1, run 2. So are these parallel? Nope. Are they opposite reciprocals? They are opposite reciprocals. So these are opposite reciprocals. So that means that they are perpendicular. So then I do know that there is a right angle in between those two. Things that are going uphill are always going to have positive or negative slopes. Positive. If they're going downhill, negative. It is a good habit to double check after you're done. My red line is going uphill, positive slope, good. My blue line is going downhill, negative slope, good. Because that is literally the number one mistake, people losing negatives. Yeah.
My 8th grade algebra teacher told me that you could just look at the graph, and it'll just show you that if it's climbing from left to right, if it's climbing from left to right, it's positive, but if it's going down, it's negative. Like it's going down from the top.
And they call that increasing when it's going up and decreasing when it's going down. And you'll definitely need that for algebra 2. All right, cool. Okay, let's go down to the bottom. Can you take a minute and find the slope of all 3 of these lines? Because we want to be able to write some equations, but first we need the slope of all of these. So go ahead, I'll give you a couple minutes to do the slopes of all 3 of those pictures. Just write the slopes like above the graphs, because we're going to write some equations below it. Don't miscount bubbles, and don't jack up your negatives. You can use the dots that they put on, or you can make your own dots if you find other pretty ones. It won't matter, they'll simplify all to the same thing. Got all 3? Yeah? Okay, so for the first one, how much did you have to rise and run? Rise what?
Down 5 over 2.
So you wrote what? Negative 5 over 2. Okay. Next picture. Rise what?
Rise.
Did you do negative 6 over what then? If you went negative 6, that means you went down 6 and you went left 3. So if you did down 6, it would have to be a negative 3. So it would be a negative 6 over a negative 3, which would really be a 6 over 3, which would really be a 2, right? And if you went the other direction, you rose 1, 2, 3, 4, 5, 6 and ran 3. So that would be a 6 over a 3, which would be a 2. So either way, you're going to end up with positive 2. Plus, this is uphill, right? If this is uphill, he better have a positive slope. So that will tell you if you messed up your negatives or not, right?
Wait, so is it 6 over 3? Is it positive 6 over 3 or negative 6 over 3?
Positive. Because either you had positive over positive, which is a positive, or you had negative over negative, which is also a positive, right? It will be positive when you're done. What about this guy?
It would be just 0 over 5.
So you would have ended up with 0 over 5, right? Because you don't rise at all, you just run. And what is 0 over 5?
0.
Just 0. If I have $0 and I divide it up among the 5 of you, you owe me about $0, right? No. You're allowed to have 0 divided by something, you just can't have 0 on the bottom. If you have 0 on the bottom of a fraction, then what kind of line is that? Vertical. So 0 on the top, horizontal, 0 on the bottom is vertical, and remember we call those undefined. Okay, so the directions for this actually said to write an equation, 2 equations for lines that are parallel and perpendicular. So we need a line that would be parallel, and we need a line that would be perpendicular to these guys. Okay, so let's go underneath here and let's find some lines that are parallel and perpendicular to them. Let's look at this first picture. I want to keep my slope visible. Okay, here this is. Let's think of a line that would be parallel to it. If the line is parallel to it, how many lines are parallel to this first picture? How many lines can you think of? Is this line parallel? Is this one? 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 Aren't there millions of them?
Yeah.
So all they have to have in common is what?
The slope.
Same slope. So any of these lines that I drew would have the same slope, right? So all I need to do is write an equation of a line. So let's put a little symbol for, let's do parallel first. So all I have to do is make up an equation that has the same slope. So I could just make one up. Y equals, what does M have to be? Negative 5 halves x plus, make me up a B, 50, sure. And if I were to type this into Desmos, I would end up with a line that is parallel to this. Now he would be really, really high up in the sky, but he still would be parallel, right? So as long as the slope is the same, you have a parallel line. Millions of possibilities, right? If I wanted to make a line that was perpendicular to it, what might that equation look like? Y equals 2 over 5. You forgot one little thing. X. And now, do you have to pick 50? Could you pick a negative number? Let's just random pick a negative. Negative what?
70.
3? 30. How's that? Okay. These two lines, if I were to graph them, one would be parallel to this and one would be perpendicular. Okay, go ahead and make up 2 equations for your parallel perpendicular for this guy. Parallel and perpendicular. Oops, that was ugly parallel. But make up two equations for the parallel perpendicular to the second one. Okay, somebody give me their parallel one.
Y equals negative 3 over 6 minus 10. Oh no, wrong one, I'm sorry. Y equals 6 over 3x plus 10.
Would this be okay? Yeah. You could have also used just 2 right there, right? Okay, someone else give me their equation for a perpendicular line. Negative what? Negative 2 x what? Plus 20? Sure. Will those work? Yeah? Okay. Let's quickly review. What do horizontal lines, does anyone know what the equation of this line in this picture is? If m is 0, think about an equation. So think about y equals, if m is 0, that means 0x. What's my y-intercept in this picture? Y-intercept is where it crosses the y-axis right here. I heard 1. So plus 1. So the equation of this line is this, right? But we don't write 0x, because if we have 0 x's, we don't have any x's. So people just write, the equation of this line is pictured as just y equals 1. Y equals 1. Okay, so if I want a line that's parallel to it,
Negative 1 over 5.
a line that's parallel would be y equals what?
1, negative 1 over 5.
Y equals 17. Where would y equal 17 be? I would go up to 17, way up here, and draw a horizontal line, right? Okay, so a parallel line would be y equals 17. A perpendicular line. Now, how do we write vertical lines? What did those look like? Do you remember? Let me draw one on this graph. If I were to draw this line, this pink line, does anyone remember what the equation of that pink line is?
The y equals
There's no y in it.
x equals
What? The zero's on the bottom, which makes it undefined, so it's illegal. So remember, we write x equals, where does it cross? The x-axis. What number is that? 2. It crosses at 2, right? Because that's a 2 right there. Okay, so this line would be x equals 2. So if you wanted to do something perpendicular, you need anything x equals, give me a line. Negative 3. If I said x equals negative 3, that's 1, 2, 3. That's back 3 spaces. That's right, oopsie, right there, right? Fold him and tuck him into page 24.
check the announcements for today, just check town.
I